Hello, my name is Brian, and I'm here to hack on TigerBeetle. So TigerBeetle is a financial database written in Zig, but I'm not going to be hacking in Zig today. I'm going to be hacking in Rust. The project I'm working on this stream is implementing the Rust client for TigerBeetle. So TigerBeetle has clients for a number of languages, Python, Java, Go, others perhaps, JavaScript surely. But no Rust client yet, and there's some demand for Rust clients, and will be more in the future. So I'm doing a project to make those clients available and streaming the whole thing front to back. We've done something like 9-10 episodes of this stream so far, and it'll be many more until we're completely done. So tune in if you want to see this whole Rust project. The TigerBeetle clients are all bindings to a library called TB-Client. TB-Client is a static library written in Zig, exposes a CFFI. And so the Rust client we're writing now is also bindings to TB-Client, the Zig library. In the future, we might do a pure Rust client, but to start, we're just doing the easy way, doing the bindings. There's a lot of advantages to doing it in pure Rust, or some advantages. But we're doing the easy version first, and we'll do the hard version in the future. So in the last couple episodes, we've been kind of at the stage where we are fully implemented two requests for TigerBeetle. The lookup accounts request and the create accounts request. And these two are kind of sufficient to get us like a pattern down for how to implement requests to the TigerBeetle server. And now that we're pretty confident that we're doing it correctly, I'm just doing some cleanup. So last time we kind of cleaned up the API to make it look more rusty. Previously, we were exposing some of the underlying C bindings types all the way up to the client. And we don't want to do that. Our Rust API, we want to present Rust types. So last time we kind of cleaned up the surface area of our Rust API so that it doesn't have any more C types poking through. And this time I have one explicit goal for this stream, and then maybe do a few things afterwards. The implementations we have, so every single request type or operation type in TigerBeetle is going to be a different async method in our Rust API. And we've implemented two, and they follow a very similar pattern. So there's lots of boilerplate there. And when I say lots, I mean like a screen of boilerplate. But a lot of it's unsafe code, and copying and pasting it is very error prone. I've made errors almost every time I've copied and pasted this code around. And so before we continue, I kind of want to refactor this code and extract the boilerplate into a support method so that when we go implement our remaining requests, they'll just be calls to the support method, which we're already confident is pretty correct. And we may learn new things that tell us that the support methods we're going to create are maybe not, complete yet, but it'll be nice to have all that tricky FFI code kind of extracted to one place so we don't keep screwing it up in the copy paste. And so let's go ahead and go look at the code and see where we're at. I think we're going to need to do a little bit of housekeeping before we really get started. And let me expand my windows so they're a suitable size for streaming. Forgot to do this beforehand. Just make this perfect right there. And let me also go and make sure I've got my streaming browser screen working correctly in OBS. Another thing I forgot to do. Okay, there we got. All of our scenes are working. And every time I, refresh myself on a project, come do some more work on a project, I always got to kind of remind myself where we were last time. And so I've accumulated some junk in this project. If I figure out what branch we're on, we're on the Rust client branch. But if you've watched the stream before, you'll know that the way I work is I just commit lots of junk, right? So my commit history is large now, but it's all kind of meaningless commits. So I kind of want to clean this up. And if we look through the rest of my history here, a lot of temporary checkpoint commits here. The branch that I ended up basing this off of, because as the project goes on, I'm rebasing and rebasing. And at some point I rebased on this branch, and this is not like the upstream main branch that I should have rebased on. I just happened to rebase on like whatever happened to be on my local main branch. So this is kind of a weird commit for me to be building this project off of. No harm, but I really want to rebase on whatever is currently a main upstream. So we're going to clean up this history a little bit, just do a little housekeeping, and then we'll get going. So what I think I'm going to do is I'm going to kind of see where we are and, push my current branch to my remote in case I really screw up. I'll at least have it on the remote. And I'm one commit ahead of the GitHub now. So I'm going to say git push, and I don't have this linked to an upstream. So I'm going to say git push Burson. My name is Burson on GitHub, BRSON. If you want to check out my socials, they're on my github.io page, burson.github.io. All right, and so now I'm all synced up with GitHub. And what I'm going to do here to clean up this mess of history is I'm going to go find my upstream, which is this main commit, and I'm just going to reset onto this commit and wipe out all these checkpoints in my history. So I'm going to say git status and make sure everything's clean, and then git reset onto that commit. Now I'll have just a bunch of dirty space here. And this represents all the work I've done on this project so far, and I'll just create a fresh commit. And again, I'm not going to care too much about what the history looks like. This is just, checkpointing incremental progress. And now I'm going to rebase onto the actual upstream main branch, which is origin main. Git log origin main. You can give it a look. There it is right there. So git rebase origin main. And now our history looks a lot more sensible than it did at the start. To make sure this is all working, I'm going to do a real quick smoke test. I'm going to rebuild the server. I'm going to rebuild the client library, the TB client static library. As we mentioned before, I don't have the build system completely set up to tie the static TB client library to the Rust crate. Like those things don't build at the same time with a single command. I've yet to set up that build system. So every time I, make changes to the underlying branch I'm working off of in Tiger Beetle, I got to go rebuild the library. So we're going to do that now. And to do that, I have to run, this is a Tiger Beetle specific build command. In Zig, you have build scripts, which are just imperative scripts written in Zig. And our command for building the client is clients C. And this is just going to build a C static library that our Rust crate can link to. And while I'm here, I'm going to go ahead and just rebuild Tiger Beetle because we're going to need that server at some point. And while we're here, I'm going to check out my bandana. Yeah, it looks all right. All right, we've got the server built. We've got the library built. And now we can go into our clients directory under Tiger Beetle. And none of this is on the main Tiger Beetle branch yet. This is all my own code. We're kind of quickly approaching a point where we can get some preliminary work in as a PR to Tiger Beetle. But if you want to find this, you have to go check out my branch. So here's our directory for the Rust client. And I'm going to say cargo check and cargo build. Every time we kind of get started working on a Rust project, I always run cargo check and cargo build just to kind of refresh all the caches, like all those dependencies. I'm going to make sure they're all built, both for type checking and for the full build. Because in Rust, we mostly do a lot of type checking, don't do a lot of building. And we'll go for hours just type checking and never actually do a full build. Okay, and I'm going to go ahead and run our test program. Our test program is just a tiny little ad hoc test harness that's just exercising the stuff we've already done. It's not like an actual unit test. And I don't know exactly what it does, but I'm just going to run it and make sure it seems to do something. And of course, we don't have the server running, so it does error. It just errors. And I'll go ahead and run the server. We have a test database right here. And to run the server, I'm going to say build run start. And then I'm just going to let Tiger Beetle tell me what the arguments are to the server. Addresses equals that. And the path to our database. And that's enough to get the server running. Now when we run our bindings test, it should do something. Great. So now I'm confident that our rebase all kind of worked. So now we can really get started doing something. I'm confident that our rebase worked, so now we can actually push our rebase and overwrite our remote on GitHub. So I'm going to say git push person Rust client and force push. All right, now let's go find our code and kind of see where we are. This is in clients, Rust, source. Everything is going to be down here. This lib is all the code to the client. And then we have bindings in a lot of places, but these are the Rust bindings right here that are auto-generated. Most of this work involves kind of cross-referencing what we're writing with some of the bindings code. And we've done a lot of cleanup here, but it's still kind of gnarly. Like this here is all just telling Rust, the compiler, like, don't worry that the bindings look gross. And these are all public right now, but none of this is going to be public eventually, because it's just a C-style Rust code. And here's one of our methods for submitting a request. And in the other pane here is the other method for submitting a request. And we can see that this code looks very similar. And the differences are subtle enough that it's super buggy. If you had to maintain these two things alongside each other, you would make mistakes. And in fact, every time I go back and forth between these methods, I'm making mistakes. So these methods involve a few steps. You can see here on the left pane. The first thing is we create a packet. And the packet is the thing we're submitting to the underlying TB client library. And this is a big step, and this is very boilerplatey. A lot of unsafe code here, casting between Rust pointers and unsafe pointers. And then we wait for a message, and then some of this follow-up stuff is kind of request specific. Like here, this is not request specific, this is just handling an error. But then down here, like the way we handle the result of each specific request is not identical. So the obvious thing for me to do to get started factoring out some of this boilerplate is to take this packet. You can see here, we've already kind of taken all this packet code and encapsulated it in a block. So the obvious thing to do is take this block and just pull out this block into a function. And I love this kind of work. This refactoring work to kind of beautify the code is a big part of our janitorial work as hackers. And I really love just stepping back and trying to make the code more beautiful. So I'm going to go ahead and kind of just start outlining something. And I'm going to go ahead and put it right here after this impl, and we'll move this around later. But for purposes of cross-referencing what we're doing, I'm going to create a helper function right here. And it's going to call it create packet, and it's going to return something. This is probably going to be a packet T, the underlying C library. No? Yeah, yes, it's this thing, this boxed packet T. And don't know if it's possible for there to be errors or not here, so I'm just going to say we have a box of TBC TB packet T, and then just to do. Who knows what goes here yet? And we'll just cargo check that and make sure I've typed the method signature correctly, or the function signature. And then I'm going to swap windows. Window swap. There we go. Remember, on the stream, I want to do my work on the left pane so it's not obstructed by this big window of me on the right pane. And how do I want to do this? Basically, everything that I'm doing here is going to be part of this method. And I know that I'm going to have some kind of input, but not a lot of input. And it's going to be type specific. So I think I'm going to start by saying, let's just take this callback and construct the callback first. And we'll get that to type check. And just looking at the code that I'm moving into create packet, I know I don't really need this block anymore. So this block is kind of the function we're creating. And create packet is probably going to have to be parameterized over some kind of type, like probably two types. There's probably like an input type and an output type, or an input type, a Rust input type, and then a C input type, like this TB account T, this events. These are the input types to the underlying library. And I'm kind of looking whether these events here are captured here in this closure or not. So I have events, just searching for the use of events. Events length and events length is here. Data size. And I'm not seeing, okay, here's where we capture the events way down here. So the events are not captured in this closure. And again, one of the things to remember, that to explain here, is that the code here is out of order. So in this, because there's callbacks involved here. So this code is not the first code to run. And when I was just now looking at this code, I was like, well, surely we're doing something to transform this events input, because this is like where we're handling events. But this code doesn't run when this function is run. This jumps all the way down to here, and this is the first code that's run when the function is run. Because this is just constructing a callback and making captures, and it's stuffing the callback into this packet request, and then that callback gets gets run sometime in the distant future. So right now we're constructing this packet, and we need to know at least the C type that lives in this events buffer. So in the underlying API, there's this packet.data field, and this is some number of elements for a specific type of operation. And these the types that go in that field or in that array are defined by the underlying C API, and they're specific to the operation. So this events data pointer is just a pointer to some number of U8s, and that's just a buffer that holds a type-specific struct for every single operation. So I'm going to go ahead and start type parameterizing this create packet method. Like I know we need a C input type or an event type. So I'm going to call this type event, and I'm going to give these like full names for now. It's common in Rust to like have, you know, one letter generic type names. But I think we're going to have at least 2 generic types on this function, maybe 3. And at least for starting off, I'm going to name them clearly. So I'm going to call this C event. So this is the type of event for the underlying C API. And that's going to be not TB packet T, but this TB account T. This is the underlying C type that gets stuffed into that array. So that's a C event now. And this is kind of like the whole deal of factoring out this function is going to be, we're going to be creating a generic function. So we're going to take the types that are concretely different here between our implementations and turning them into generic types. And as I'm saying that, I'm kind of wondering, should we extract this in a non-generic way first, type check it non-generically, and then convert it to generic method? And I'm liking that idea. You know, let's be very incremental and safe. So I'm actually going to just take this whole thing down here. I'm just going to type check this just the way it is. And I think we can put a to-do here. And this here is just constructing a callback, so it doesn't depend on any input to the create packet function. This should type check. So let's just see if that type checks. Okay. So this needs a channel. So in this API, the way this API works is that when we get the callback, it's on another thread. And that's the callback saying that the work has been done on the server and we've got a result. And so the way we handle that callback is we send a message back to the original thread on some kind of channel. And so we're going to need some kind of channel here. And I'm just going to create the channel right here in the create packet method. We could probably pass in like the sender and or the receiver. Maybe this just the sender in. But we're going to create the channel here. And that also might mean we need to return it. Like here, we're going to get the packet and also the receiver of the channel possibly. I'm not going to deal with that yet. Let's just get this checking. And again, a lot of these variables are probably unused. Like this variable is unused right now. This TX, the sender transmit, that's used, but this is unused. But right now we have allow unused here, so we're just ignoring all the unused variables. Okay, so that type checks, and I'm going to go ahead and start pulling out the rest of this code for create packet. And just get this to type check. So now this, once this type checks, it'll be suitable for one specific type of event, and we'll use it for the specific event, and then we'll make it generic. And I know this is going to need this events input. So I'm going to go up here, and again, events is defined right here for the submit create account request. And this is the tail expression of this whole function. So this should be the whole thing, and this is now duplicating exactly the body of submit create account. The big difference here being that this is not duplicating the body of create account. This is duplicating the body of this block that creates the packet. All we're doing is creating the packet. Everything after this block is not part of this abstraction we're creating right now. So I'm going to see if this type checks, and I expect it to, and it does. So then we can extract all of this stuff for packets. And we can say let mute packet equals create packet and pass it our events. And this, we don't need this channel because we're creating the channel here. It's a channel of completion message of TB account T. Okay, that seems okay. And now we don't have that RX, so we're going to get an error here because we no longer have this down here. This receiver that's receiving the completion messages doesn't exist anymore. So let's at least see that error. You can see it right there. You know, RX is not found. So to resolve this, we got to make it, we got to return it from the create packet method. So we just return a tuple. So here's our packet, and here's the receiver to receive the message for completion on. And we have to name this type here. So it's going to be, this is a futures. Let's go look at our imports. I don't remember what this is called. Right here. It's right here. We've already imported a receiver. So we're going to say receiver I before C, C before I before E, except after C is the way it's said, is a receiver of something. And if we go look at our submit create account, what is it right here? It's a receiver of this, of completion message, TBC, TB account T. Let's make sure I've got all my closing braces here correct. I think I do. And this is a pretty long line. I think it'll be more readable if I split it up like that. And I was hoping Emacs would indent this like this, but it was not clever enough for that. Unless I have a syntax error, which I do. There we go. Let's see what I did wrong here. RX not found in the scope because I didn't adjust this here. This is let packet RX. And I didn't return the right thing down here because this is going to be let packet equals this, and then we return a tuple. This is a tuple of packet receiver. Okay, so now this, we've extracted, the body suitable for submit create account. Let's run our test program real quick and make sure it looks like it's basically working. Cargo run. And it looks like it's basically working. So I'm going to checkpoint that work. And now I'm going to, remember we have one more method that is using this code that needs to be extracted. And before I try to do that though, I'm going to make this create packet method generic in the way I think is going to work for the other method. And we'll get this generic version of create packet all type checking. And so I'm going, and then we'll try to apply it to our lookup accounts. And I'm going to create a type, some type parameters here. And so we got this beautiful indentation here. We have type parameters, value parameters, and then this tuple of return types. Pretty nice. So we're going to need at least two types here. There's going to be the Rust input type or Rust event type. This is going to be the C event type. And then is there some other type involved here? There's going to be some other types. There's some other values involved here, like this TB operation create accounts. That is a C enum that defines which type we're doing, and it has to match the types we're using as inputs here. But I'm thinking there's some kind of results type we need to account for as well. But that might actually not be dealt with in the create packet method, because for every request operation in TigerBeetle, there's a type for the request and there's a type for the result. And here we're really only dealing with constructing the request, so we probably don't need to deal with the result type at this point. So I'm going to say that there's probably two type parameters here, and one is the Rust event type, and one is the C event type. And I really wish Emacs would indent this in a better way. I'll just go with what Emacs likes and put these all on one line. And I'll go ahead and try to put these in the caller as well. The Rust event type is going to be account, and the C event type is TBC TB account T. And then everywhere those two types, the account and TB account T, appear in this method, they need to be generic types. So this TB account T is the C event. TB account T here is the C event. TB account T here is the C event. This TB account T here is the C event. And account is, here's TB account T here is the C event. Wow, this type appears so many times. I'm glad we're doing this. So error prone to have to copy and paste all this stuff around. And then this account T here is the Rust event. And it's only named here, but it is used down here. And this depends on having a from implementation. So we're going to need an additional constraint on the generic types in this function. But let's see if so we're going to need an additional constraint on the generic types, because the implementation says, we're going to use an implementation of the from conversion trait in order to convert the Rust event into the C event. And so without further information in the type signature of this generic method, the compiler doesn't know where to get that from implementation implementation from. And I'm going to go ahead and try to compile this. First, I'm going to just search for TB account T, TB underscore account T. Okay, doesn't exist anywhere else in that method. So this is almost enough to keep compiling, except I believe for that constraint on this generic method, on the constraint on implementations of from for C event. But I'm going to see what the compiler thinks now. I'm going to say cargo check. And how many errors is it saying? Some errors. Pretty straightforward. Okay, so copy is not implemented for Rust event, so we know we have to add a copy parameter. And here it just tells us what we need to do. Copy. And let's build again and see if it tells us the next thing we need to do. And it says from Rust event is not implemented for C event. And this is what we hypothesized was going to happen. And it tells us exactly what we need to do. So that's very nice. Yeah, that's from Rust event. So C event has to implement from Rust event. And let's see what else the compiler doesn't like. And here it says the parameter type C event may not live long enough. Okay, probably we need to do exactly this. C event, we got to tell the function callers that, yeah, definitely this C event doesn't capture any lifetimes, because the C event is going to be captured in a callback here. I'm just wondering why this C event, the compiler thinks this C event is going to be, is there a capture here? There's no captures in this callback. Returning a completion method of C event. Probably relates to this receiver, but it says it's related to this callback. So that the type C event will meet its required lifetime bound. Parameter type C event must be valid for the static lifetime. Well, this is the type of error in Rust that I have seen for many years and I still don't understand. So I know what I need to do. I need to tell the function signature that this contains only static lifetimes, but I don't really understand from the error message here, what the chain of analysis was that led, this block to think I needed an annotation. C event is plus tick static. I'm guessing it has to do with this capture here, this capture of the completion method of C event, but I don't know. Okay, that's enough to type check it though. And now this is a pretty ugly bounds here. So I'm thinking I want to move this stuff all into a where clause, because this is just kind of ugly to read in a straight line. But let's commit this, give it a little checkpoint first. So a where clause goes after the return type, I think. So here I'm going to say Rust event is copy and C event is from Rust event. A where clause is just another way to write bounds of your generic type parameters. And if you're doing very sophisticated Rust programming, the generic types can be really complicated. And punting them down to a where clause kind of out of sight of the main type parameters can be much easier to read. So Rust event plus tick static. And now we can get rid of all these bounds and just say, these are our type parameters. And if Emacs indentation rules agreed, then we could do this and make it look like that. And so now we have our generic parameters, our concrete parameters, our return values, and then our where clauses all kind of like beautifully laid out in a big tower. But Emacs doesn't like indenting this in this way. And ultimately, Emacs is not going to be the decider of who gets to indent how. We're going to just run Rust format and it's going to do whatever it's going to do. Okay, so let's checkpoint what we've got there. And now, this is generic, but it's not quite correct. I know it's not quite correct because there's at least this crucial piece of information here saying that this is the type of operation that we are submitting. And this looks like, this is the only thing I can visually see that is still not fully generic. And so up here, we're going to say create packet and give it an operation. And this is probably just a U8 here, but let's look at the underlying Rust bindings and see if it has like a type def for the operation or not. So if we look at TB packet T right here, operation is just declared as a U8. So we're just going to call it a U8. And it might be nice to assert that U8 is in the, like right here, put an assert that the U8 is in the right range just for sanity. But I don't think we have the appropriate definitions in our bindings to allow us to know the exact range of valid operations. So we're just going to have to assume it's correct, and then the TB client will surely give us some kind of error if we screw up the operation number. So op is a U8, and put a comment here like saying, I don't know if you can put a dot comment here or not. Even if you can, I don't think the Rust doc will interpret it as a dot comment. Let's put a little comment here saying what defines this operation, because this is untyped, right? This is not giving the reader a lot of information on what this op even is. But I think it's going to be this TB operation, and you can see here. Let's count right now how many operations there are, because on these streams I've been saying, there's around 6 operations, but it looks like there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 operations. And this pulse operation is kind of an internal thing I don't think we'll ever deal with. So I have 1, 2, 3, 4, 5, 6, 7, 8. 8 operations. Well, I got 2 different counts, but it looks like 8 operations that we have to implement. And we'll say this is a TB operation. And so then when we call it, we're going to call it as with 2 arguments now. And this argument is going to be equivalent to this thing we've already put in here. And we're not going to actually take a U8 because there's a cast to U8 here. In our bindings, the field says it's this enum variant here is a U8, but defines the constants for that field as U32s. So our argument up here is going to actually be a U32 because all these constants are actually U32s. And then we'll cast them to U8s. So if we think about the assert we said we might make here, like we know these U32s actually have to fit into a U8 range. But still, I don't think it's worth asserting that. We'll just let the underlying library figure it out. This is all internal code anyway, so it doesn't really matter whether we're not going to make a mistake with this ultimately. Okay, so now we're passing the correct operation type in. And if we just think about what we've accomplished here, before we had this big open coded mess here. We got to make this op here. But this was shared between all 8 requests that we have. Very prone to errors with all the copy pasting. And now all of that has been reduced to just call this thing with 2 type parameters and 1 operation. This is much easier to deal with as we go write our other requests. So let's type check this and make sure it seems to still basically be working. And still seems to basically be working. But I note that the request we're submitting here generates only errors. So before we continue, I'm going to make sure it's still possible to generate a successful request. This is a sanity check. So in our main program here, this is just a little test program that we've been maintaining to exercise the library we're writing. I'm going to create 2 new account IDs because we've been attempting to just create accounts that already exist. That's why it's returning an error. So if we create new account IDs and run it, these should return, successful results. And then this lookup, these are lookups that found those successfully created accounts. And give me 1 second here, chat. I gotta sneeze. My nose was itching, just like suddenly itching everywhere, and I was just panicking. Like, oh gosh, I got to keep talking and finish this thought, but not sneeze. But it's done now. All right. I think I need a little more refreshment before we continue. So, give me one more second. Just making sure everything's all cleared out. No boogies on stream. All right, so this is all working. This generic function works for the one case we've applied it to. And now, let's see, did we checkpoint this? Git status, nope, let's checkpoint what we got there. And we're gonna reuse this create packet in our other request. So all of this is gonna boil down to, well, let's not do the work down here. Remember, we need to do our work on the left-hand pane. So we're going to take this, copy this much smaller amount of code into submit account lookup. And now these three things that have to change here, we just got to change those. So our event is now a U128. Our C event is what? It might just be a U128 again, but I'm not sure. I think it's still a U128. I wonder if there's a C type. I don't think there is. I don't think there's a type alias for, so this U128 here is just the ID of an account. And Tiger Beetle doesn't define like a type alias for account ID. It's just U128. So this is also going to be a U128. And this create accounts is, delete, well, don't delete it yet. This is not create accounts, it's operation lookup accounts. And now we can delete all this boilerplate. All right, and now this should build and should still continue to work. Check, run. These results look correct still. So we did it. We extracted a generic method for all that packet construction boilerplate. Now the question is, do we want to extract any more generic functions to deal with some of this other code? So this is all the kind of setup code for building the packet. Let's look at both methods here. And some of this is duplicated, but it's not a whole lot. Like this code is duplicated between the two methods. And so far, that's not really enough to like set off my code smell alarms. Everything after that is, well, this is not super different. So both of these are like accumulating results. This pretty similar. The logic here did take us several iterations to not screw up. So it'd be nice if we could extract this loop here. Let's look at what this, okay, so here's we get a slice of result types, and these are different. So the method for getting a slice here is somewhat different from this one, though looking at these two distinctions, I'll make sure you can see these above my face on your window. We're looking at, here's how you get the result slice from get lookup or account lookup, and here's how you get the result slice for create account. And you notice there's an extra clause here. There's a special case here in this one, and it's making me think like maybe that special case is supposed to exist here, but we actually didn't run into the situation that has that case. And I think that's actually true. So in Tiger Beetle, the underlying protocol, it tries to not return any response at all if it can. So a empty result will have some kind of meaning, either like it was a success or failed to find an account. An empty result has meaning. And I'm guessing that in our tests of lookup account lookup, we just haven't run into the case where all of the results were empty. And that's why we don't have a separate branch here. So probably it might make sense to like extract all of this stuff into another method, because I've already, looks like I've created it looks like I've written a bug right here. And we can probably even go test this, whether there's a bug in our main program. And the problem here, if we look at it here, is like if this result is just at this stage a vector of bytes. It's a byte buffer. And here we're casting it to a slice of a specific type for the request. But there's a special case here when the byte buffer is empty. The underlying array pointer inside this vector, we can't just reuse it to create a slice. And in fact, the core library or the standard library noticed that we were doing that at runtime last time, and was like, this is not a pointer you can construct a slice from. It was some kind of sentinel value for dealing with empty vectors. And so we have to handle that case explicitly and construct an empty slice. So we should probably have to do that over here. And I think we can test whether we have to do it over here by modifying our test program. So here we're doing a lookup of some accounts. And if an account is not found, then the server returns an empty result. But here, some of these accounts are always found. So we're never getting the case where we return where the server gives us all empty results. But if we change this buff to be more like that, this account doesn't exist, and we run this, we should hit the case where this is incorrect, and this should panic. Let's see if that assumption is correct. I syntaxed. Let's go unsyntax. I wrote a syntax error. Okay, here we go. Exactly what we hoped. This is the thing. So slice from raw parts, we used it incorrectly. And the standard library was smart enough to figure out that we passed in this bogus sentinel pointer from the empty vector. I'm curious what the value of that pointer is, that it was able to detect it. You can see the error message it gave was not directly about like, oh, we misused the pointer from the vector, though it probably could be smart enough to guess that situation. It was just kind of generically like, this pointer is not in a reasonable range. Aligned to non-null. I'm wondering if this is I'm wondering if it just gave us a null pointer here in our, so here we're taking the pointer out of the result vector and casting it. I'm wondering if this is a null pointer. So internally to the vector, I don't think it stores a null pointer for an empty vector, because the vector is subject to Rust's clever space optimizations. I think the internal pointer is non-null. Anyway, we're not allowed to do this. We have to do exactly this pattern. So I'm going to copy this pattern over here. We'll have to kind of like keep in mind for future test cases, like we need to test those cases where all the results are empty. We're not writing any tests right now, but eventually we'll need to write some pretty sufficient tests. All right, so here now it works, doesn't crash, doesn't panic, and it says not found. So that's, good. Found that little bug. Let's get rid of this test code here. So this is telling me like, yeah, there's a lot of like boilerplate here that seems useful to reproduce. Let's just look at it real quick and kind of make some decisions about what we want to try to extract from this boilerplate. So if we look side by side, let's make sure we're looking at two different functions here. So on the left side is the account lookup. On the right side is the create account function. I'll center it here on this async block, and I'll center it, yeah, on the async block. Nope, I'm going to center it right here. So this code here is all identical. This code here is identical except for the types being casted. So this is, the process of extracting this looks very similar to what we already did for the packet constructing, the create packet function. Just pull out the method and make some generic types for the types that are receiving unsafe casts. This loop down here, I'm suspecting it's going to be more complicated. There's going to be some logic inside this loop. But let's kind of look at what is the same and different inside of this loop. So this loop, what this loop is doing is it's going through the array of results we've received from the server, and it's also simultaneously looping through the array of input events. So it's going parallel iteration through both those things, and it's figuring out which results correspond to which event and kind of like zipping them up into one vector to return to the user. Because like I said before, the server likes to return empty results for space reasons. So we're kind of reconciling those empty results with the non-empty input events. And that process, the iteration there is basically the same. The iteration logic is the same. We're going to be iterating over all the input events, and then we're going to be iterating over the results. And sometimes we're going to be interpreting empty results. But the interpretation of those empty results is different per event type. So if we look here, this logic all looks, this looks the same. We're just setting up iterators and starting the iteration for the results. Just pulling the next event. Every time through the loop, we pull the next event. Then here, there's some differences here. So with this result accumulator, we're needing to store, there's a difference right here. The events, we're counting the events in one case, and in the other case, we're not counting the events. Presumably that's because for the create account case over here on the right, we need to use that index into the original event array to do something. But we can reconcile these two in one generic function just by always enumerating the events and in one case not using them. So this is a pretty easy difference to reconcile if we create a generic function here. And down here, we're looking at the logic for, what happens. So this first case is like, what happens if there is no next event? That's kind of the termination case for the loop. If there is a next event, then we're doing this nested logic. And the nested logic should be the same for both event types. But here, this result is for event. These are two different pieces of code. So if we created a generic function here, if we extract a generic function, we'll have to pass in, something to that function to figure out how to do this comparison in one case and this comparison in another case. And remember, this next result and next event, these are going to end up being generic types. So this will be completely, this will probably just have to be like a closure, just passing in the types, passing in these values and letting the caller use a closure to say this is the logic for figuring out if this result is for this event. And then this logic all looks similar. So if this result is for the event, then we kind of push the result onto our result accumulator vector. And if it's not, then we keep going. If the result is not for the event, then we push some types event specific value. Okay, so this value, this enum that's being pushed onto this vector is specific to this event, which means that this case here, this case here, this case here, like the creation of these values is all going to be parametric. We're going to have to specify that by the caller. It's looking doable, and I kind of think we should do it for fun. Like, this seems like a fun thing to extract out. And again, this logic here this isn't trivial logic. I hate to duplicate this 8 times, But as a generic function, this is much less straightforward than the create packet function we did earlier. But as practice, I kind of want to do it to see how it comes out. Kind of want to do it. So let's try it. Let's see how far we get. We're going to extract. I'm kind of wondering, should we extract all of this into one big function, or should we kind of make this one function and this down here another function? I think we'll do the former. So here we have create packet. Let's create another generic function, and we'll call it collect results. And for now, we're not going to make this function an async function. You'll see here we have to return a future here. And in fact, we're going to need to be an async function because we're going to have to call await. Although we could call await in this caller and then have the results be collected down here and not deal with the futureness in this collect results function, which I kind of like. Like the only await in this async function is right here. So we could just make the caller do this and then have all this be extracted to a generic non-async function. I kind of like that for now, at least. So here we're going to say the return value here is going to have to be this vec that is right here. And I'm saying it's a result of vec because there are probably, is it possible for there to be an error? I think actually, yes, this could be an error right here. There's one error case so far. Everything else is an okay case. So let's just take this. I'm kind of dreading this refactor here because it's a lot of things to make generic here, or a lot of parameters to extract. This is going to be a result of a vec of this. And here we can submit the packet. And for now, we're going to have the caller do the packet submission. But down here, all of this, we're going to try to extract into a function. So I'm just going to go ahead and do it. And if we type check this, it's going to be a disaster because we're missing all kinds of parameters. We definitely need, or go ahead, I'm not going to try to type just text this yet because there's a bunch of stuff I know we have to do. Like we need this message type. And this message type is defined where right here. It's a completion message of C event. So this message is completion. This is a completion message of a C event. So we know we're going to need a C event generic type, like we used on our previous generic method. And this C event, we had this from Rust event. I don't know if we're going to be dealing with this Rust event here. I think we're not going to deal with this Rust event at all. The C event, we probably don't need to declare it static here. So for now, we're going to have no where clause. This error handling we know is going to be the same. There's nothing generic there. This is generic. Let's go put it on our other window here. Let's collect results. These two are the result type. So I'm going to call these generic types C result. Down here we're going to cast C result. And let's keep looking through our function here to see what else looks generic. Eventually, we're just going to have the compiler help us, but we're doing a visual inspection to try to figure out what parameters become generic. This is kind of the big thing that's going to be a thorn in our side for making this extracted function generic. This is the return type that is event specific. I'll put it over here in the right-hand pane. And it's also here in the, so this is a C result, and this is going to be, we'll call this Rust result. Big part of this function is going to be converting the underlying C-type results into Rust results. And so we know we need a Rust result generic type. And that Rust result generic type is this. And let's look at what this cast is. We already know this is going to have to be an input, and these three things are going to have to be inputs. I'm just going to keep going trying to imagine what all the failure cases here are and just keep trying to just write out all these type parameters myself for arguments. So if we look at this, in both cases, I'll show you again over here. In both cases we have so far, there's one case that just returns a value. This account lookup OK not found, or a create account OK success. This is the case where the server didn't returned an empty result, but the meaning is different based on the event type. And so just from seeing how this is used here in these two cases we have so far, it's just a plain old value. So we can pass that in as a parameter. Like this is the value to return for empty cases. So in our collect results, I'm going to say here's our message. And this is the empty result is a Rust result. And this suggests that probably the Rust result is going to have to be copy and or clone, because we're going to have to make copies of this empty result in order to pass them back or push them onto our result vector and pass them back. But I'll let the compiler tell us that. The compiler should tell us exactly what to do with this generic type argument to make it copy and or clone. And so here down here, we're just going to say push empty result. This is actually more readable immediately because this empty result has a name. And now I only see two cases here that need to be handled. One is this comparison, which probably has to be a closure, which is going to make this generic function pretty darn ugly. And then this. This is probably also going to have to be a closure. Although actually, it might be a very simple closure, not even a closure, but a function. Because we have to construct this variant. Let me put on our page our other case. Here's our other case. In this case, we have to construct some variant from a next result value that has been converted here from the C result type to the Rust result type. But this conversion from the C result type to the Rust result type is the same across both implementations. It's just a call to into. But this into function is generic. It's going to be an implementation of into. And so that's going to have to be a generic bounds on our type parameters of this function. And again, the compiler should just tell us what that bound is. But this function is a different function per invocation. So we're going to say this is, we'll call this a non-empty result. And this is a function, not a closure, but a function. We could make it a closure, but it doesn't look like we need a closure. So I'm going to say empty result, non-empty result. And I'll be very curious if we succeed in extracting this generic method for these two request types. It'll be very interesting to see if this method holds up after we add all 8 request types, because It's pretty gnarly already, and we haven't even gotten it working yet. And this is going to be a function. I'm kind of wondering whether we should define it as a function or a closure, but I'm going to say a function. And this is a function of Rust result to, nope, not a function of Rust result. What is this? There's a C event. There's an internal type here that we haven't given a type parameter to. This next result, converting it from Rust result to C result. This is the C result. What is the C result here? C event, C result, C result. Let's go look at the result types you've already defined for this API. Create account result, account. So in this API, this Rust result, I think I've given it the wrong name. Because there's kind of two types involved here as we've defined them so already. There's the overall result type for a request, and then there's the interior result type here, which is in this case account, or this case create account result. And so my naming here is a little confusing. The C result is the interior result type under the C library. This Rust result is the overall Rust result type here. So I'm going to call this Rust result wrapper, and this is starting to get a little bit mind-bending. And we need a Rust result. So in this case, the Rust result is account, and then the Rust result wrapper is account lookup OK. Naming here is confusing right now. We're going to kind of see if we can get there and then maybe reevaluate the names we've used here. This is a vec of Rust result wrapper, and this is going to convert this non-empty result function. Is going to convert a Rust result to a Rust result wrapper. Like this whole function is to wrap the result into our higher level Rust type. Pretty ugly stuff right here. Pretty ugly stuff, but we're going to go all the way and just see how ugly it gets. 4 generic type arguments are a lot. That's a lot of type arguments. All right, so let's go back and look at our code again. On the left hand, I'm going to put our reference code that's working for create account. And on the right hand side is our reference code. On the left hand side is the generic function we're working on. And we have our non-empty result that creates the wrapper result type out of the interior result type. And this accumulator is not a Rust result anymore. It's now a Rust result wrapper. And I know that the bounds on these generic types are not correct, but I'm going to call the compiler and have the compiler tell us what's wrong still. Let's do a cargo check. Okay, so there's one more thing that we haven't done here, and that's deal with this closure right here that says, is this result for this event? So this result is for event. This is going to have to be a closure, not a closure, it can be a function again. I don't think we need any capture any state. It's just going to be a function that says passes at the next result and the event index. And remember, there's 2 cases here. Let's go look at one case. These cases are different per request, so let's make sure we can accommodate both cases with the function we're going to define. Submit account lookup does something different. It looks at the next result and the next event. So if we're going to accommodate both of these implementations here, this implementation and this implementation, we have to pass in the next result, the event index, and the next event. So if you pass all those three things in, the caller can figure out how to correlate the result to the request. So here, let's say result is for event, and this is again a function. This is going to be the C event, the C result, and the index. And we're saying result is for event. So I'm going to put the result stuff first. Result, event, and then event index. And these are the underlying C types, I believe, here. And this is going to return a bool. So some higher level function programming here. Pretty nasty stuff. Again, we're committed to this path for now, though. We're just going to see what it looks like. And so instead of calling this result is for event, we're going to say result is for event. And we're not going to pass, I'm going to pass references here. Don't need to copy these into this closure. And here we have next result, next event, and event index. Let's see what the compiler thinks of this. All right, so this is what we were expecting before. We are missing bounds on some of our generic types, but the compiler is smart enough to tell us what bounds are missing. So here our Rust result, we need to create a Rust result from the C result. And we haven't told the compiler how to do that in a generic way. We just need to tell it that, this Rust result type implements from. So we're going to go back up to our function here, and we're going to create some where clauses. Where, what did it tell us to do? Rust result implements from C result. Rust result implements from C result. Let's see what other things it's complaining about. Here's a second one. Expected type parameter, found type parameter, expected type parameter, Rust result wrapper, found Rust result. Okay, I think I just typoed here. So here we're pushing the empty result type, and that's a parameter to this function. This is actually a Rust result wrapper type right here. So in the case where the server returned an empty result, we're just pushing a copy of this onto the result vector. All right, and here's some issues with copy and move. So we can't move out of this next result because it's a reference, and we're here trying to dereference it and convert it. But we need to add some kind of constraints to our parameters. And let's see, does it tell us? It tells us we could clone the value. Instead of constraining this type with clone, you could clone this value. Interesting, it doesn't get all the way there. Like what we want to do is we want to say C result implements copy. And the compiler doesn't know how we're calling this. So it's probably just being pessimistic and saying, well, you could clone it if you know it's clonable. But it doesn't tell us like the code for putting the constraint on C result. Anyway, what I think we want to do is we want to say C result is copy. Let's see if that gets us any further. Looks like it does. Empty result, so Rust result wrapper. We've also not given any constraints about how this thing is copyable or clonable. Probably we want to say this is clonable. But let's look at our definitions we've got so far for our Rust result types. No copies or clones on these. So it would be nice if this was copy or clone. Let's assume we can make it copy. As far as I know, these results are all structs of plain old data. There's no allocations within these results, so it should be copyable. I'm not going to put that on, I'm not going to derive copy for these. I'm just going to work on our generic function. We're not calling our generic function yet, so I just want to get this to type check. But it's saying our Rust result wrapper, it can't copy it because it's not copyable. And it's giving us a similar error we saw last time. Well, like you could clone this value if you think this is a clonable type. But I'm going to say it's a copyable type again. So this is Rust result. I'm putting these in the same order as they were declared up here. Rust result wrapper is copy. That should resolve that error. Now this all type checks. So I have to admit this is a very gross method signature, function signature. Really, really gross. But it seems to capture all the requirements of these two methods that want to call this function. Kind of not loving the way it looks though. But let's keep going as we've started and see if we can actually call this. Not really loving this. Let's keep going. Let's commit a checkpoint here and go up to one of our functions that uses it. And again, I'm putting the code we're working on the left pane. So up here, let's do submit account lookup. It's good enough as any. In here, let's just get rid of all this. No, let's not get rid of it yet. We need to cross-reference it to figure out how to call this thing. Collect result is going to return that. So we are going to say collect results, and then we're going to have to pass a whole lot of gnarly arguments to it. And we may or may not need to provide the type arguments explicitly. Some of them may be inferred, maybe all of them will be inferred. I'm guessing not all of them will be inferred. But let's just see how the type inference works for us. So the message is going to be this message that we've waited for. Result is for event is going to be a function. And I don't know if we can define this function in line here or not. C result, C event. And if you give type parameters here, that'll help a lot. C result is TBC account, no, U128 for this case. The C event is U128. And remember, we're implementing result is for event, and then event index. Cool. And again, I don't know if I can just define this function in line right here or not. I might need to call this, either make this a closure and have it inferred to have no state. I don't know. We're going to see what the compiler thinks about this. But right now I'm remembering, what is the code that goes here for the submit account lookup case. And remember, this closure is implementing. Let's look down here. This is the code for that case. And we can probably call these next result. This is a reference, remember, and this is next event. And then event index is a usize. And we're not going to use that. And then collect results. Next requires an empty result. This is the account lookup OK not found. Again, that's this case here where there's no result returned. It means it's not found in this case. And then the non-empty result we have to construct here. But this, we can just say account lookup OK found. And this is a variant, but is it a variant that contains payload? And in Rust, you can treat this as a function. So we're just going to pass account lookup OK found directly to collect results, and it will be interpreted as a function that creates an account lookup OK. So that's how I think this should be written. And then we can delete all this code. And that's the whole thing. And now if we just admire the way this looks before we try to get it to actually type check and work correctly, this looks very nice. If all 8 functions, have this basic outline, that'll be very straightforward. The only thing special about here is we have to say like what happens in the empty case of results, what happens in the non-empty case, and then how to determine whether the result and the event actually relate to each other. From the caller's perspective, it looks very straightforward. From the callee perspective, it's a real nightmare. This is super gross. Super gross. But it all kind of falls out of the implementation. Like, it makes sense. We'll have to live with it for a while and see what we think. Anyway, let's try to make this type check. And this is definitely going to be something not working here. And we're returning this, so we don't need a semicolon here. This is a tail expression. And okay, so it did not like just writing a function here. But we might be able to say, make this a closure, and a closure that doesn't capture, and that might coerce to a function. Because remember, we're saying we're accepting a function here, not a closure. We could accept a closure here, but right now we're accepting a function. And right here, we're writing a closure, but I remember that there's some case where a closure can be type inferred to not actually be a closure, but just to be a naked function. So we're going to see if that works. This syntax is wrong here. That should just be bool. Let's see what didn't like. Expected one of something. Expected stuff. Okay, I think I did something wrong here. Maybe this is an arrow and I forgot. Probably that's an arrow. Or next result underscore. Okay. I put an underscore here from copy pasting, but this is not an underscore. It's just called next result in this closure. Copy is not implemented for account lookup OK. Why does it need to be copy? Why does it need to be copy? I'm just seeing if it tells us enough. It's asserting it needs to be copy, but it's not really saying why. Required by bound of this function. Copy. Why does it need to be copy? Probably because it's copying that. Definitely because it's copying that. And I must not have said that. Yeah, I said it has to be copy. It has to be copy. The trait. Oh, it's saying that like I haven't actually said that the type I'm passing into this function is copy. So now it's time to go derive copy on these structs like account lookup OK. So we go down to enum account lookup OK. Now this has to be copy. And if it's copy, it's also clone. And we'll do it for this one too. That gets us a lot further. All right, and obviously this is wrong. I must have copied this case wrong. I must have copied it from the, I copied this from the create account case. So let's go look at our diff, because I already deleted the code for this case. Next result.id. No. I'm wrong. What I did was I specified the next result argument type incorrectly. This is not a U128. This is a TBC account T. So when we do a lookup of an account, the result we get back is a structure representing that account. Hey, Brongalus, I see you. Good to see someone hanging out and watching what I'm doing here. Today we are hacking on the Rust client for the Tiger Beetle database. And I'm just doing some refactoring, taking the boilerplate code that I'm using across two different request methods that look almost the same and extracting that code into generic helper methods that all requests can depend on. And it's kind of just an exercise in Rust refactoring, which I think is very fun. I love refactoring in Rust. And I'm kind of doubting myself. I find myself doubting myself about these decisions on stream a lot because one of the methods we created looks like this. And this is some brutal generic type parameters on this method. But we're kind of experimenting to see where we get here. Yeah, the comment in chat is about, Tiger Beetle is written in Zig, and Tiger Beetle is 100% in Zig, but I'm working on the clients for applications to use to talk to Tiger Beetle. And Tiger Beetle applications are written in lots of languages like Python, Java, Go. And after we have this done, they can write their Tiger Beetle clients in Rust and talk to Tiger Beetle in Zig. But yeah, Tiger Beetle is written all in Zig and always will be. It's just ironic that on the Tiger Beetle stream, much of our content at the moment is Rust content. But that's my fault. We'll have more Zig content eventually. If you check out Thursday's MatClad streams on the Tiger Beetle Twitch about Zig stuff, once a week, Thursdays at 5 p.m. UTC. Hi, Billy Harrington. Glad you came in and are checking out what we're doing. So I've been streaming this whole project I'm doing on stream. All of the Rust client is on stream. And I think it's a pretty good bite-sized thing to be streaming. It involves a lot of like typical Rust programming, especially typical low-level async programming and FFI programming, unsafe async, lots of good stuff. Very Rusty. Anyway, back to the thing we're doing here. This collect results is a generic function that is super gnarly. And this closure here is deciding, what to do in a particular case in this generic function. And I defined this argument to this closure incorrectly. In this case, the result of looking up an account is not the account ID, it's the account struct. So in that case, it's a TB account T, I believe. And TB account T has this ID field that we can compare to our input event. This closure is deciding when we interpret results in the Tiger Beetle client, we have to say, we have to look at the results and the input events and figure out, is this result associated with this input event or this request? And so that's what this generic function is doing. It's doing parallel iteration over the inputs and the results and figuring out which results belong to which event. And we're extracting that code into one pattern that can be used for every single request, every single type of request. So let's type check this and see. Okay, so this all type checks. We're calling it from submit account lookup. And I'm not going to test it yet. I want to go over to the other request we have, which is submit create account, and see if we can get that to type check with the new code. And again, I'm going to insert it right here. And on the other side of our screen, I'm going to put the code we just wrote so we can kind of crib off of it, this collect results call. And right here, we're going to call collect results again and pass it our message and a closure. This closure is going to accept a TBC TB. This is the result type of create accounts. So I think it's a TB create account result T, if I recall. And then next event is a TB account. We're creating accounts. And then we need the event index. This all returns a bool. And that is a very long line that we need to deal with at some point. I don't know if Emacs will format this prettily for me. I think it probably will not like that. Anyway, very ugly long line there. And this case is implemented down here. Result is for event, just like this. So this is like the big thing we're copying out and lifting out into the caller. Next result index, if it's the same as event index, then we know this result is correlated to the input event. And then our two cases here are what to do for an empty case and what to do for a non-empty case. And they're down here again, create account OK error and create account success in the opposite order. So I'll just copy create account OK success. That is the empty case. And create account OK error is the non-empty case. And that's the whole thing, really. Let's see if that type checks. And again, from the caller's perspective, this looks very manageable. This is looking nice to me. All of the boilerplate in here we pulled out, all the boilerplate up here we pulled out. You can see there's two little bits of boilerplate here, but that's pretty manageable. Okay to copy paste that, I feel. There's no screw ups possible over there. Let's see if this type checks. Okay, I just did a typo here. This is create accounts result with an S. Down here. And this next result, I put an underscore here, no actual underscore there. Okay, and it type checks. Now let's run it and see if it appears to be working. And it still appears to work. So let's checkpoint our work there. And now I think I want to kind of take a breather. That was everything we hoped to accomplish today, was make those async request methods that both had a ton of boilerplate, error prone to copy them, extract all that boilerplate into generic functions that we can reuse in all our other methods. Now our the work of actually implementing these methods, hold on, I'm not ready for that refresher just yet. Now the work of actually implementing the remaining 6 requests is just implementing this little bit of code. This looks much more manageable than copying around all that. Implementing this is much more manageable than copying around all this boilerplate down here. But we'll see. And I don't know if we're going to continue implementing those methods on this stream. But right now, I probably want to just step back and kind of admire what we've done and look at how horrible those generic methods looked and decide yeah, we're going to keep it or not. I think we're going to keep it because this looks like progress. Brongless, I'm glad you caught some of it. I don't have a schedule, but if you want to come back again, you're welcome. We've had a few people paying attention to this stream, and it's been great. This stream, I haven't made too many big mistakes, but a lot of the stream so far has been, me floundering around trying to figure out how to do the Rust things I'm trying to do, and then chat helping me by Googling stuff while I'm babbling on stream and finding the actual answers for how to write things in Rust. I'm supposed to be a Rust expert. I tell people I'm a Rust expert, and I market myself as a Rust expert, but man, I sure forget a lot of stuff. Really forget a lot of stuff. And there's stuff I don't know in Rust. Stuff's always being introduced to Rust. I don't really keep up with all the new Rust features and don't always keep up with all the new Rust crates. But some parts of Rust, like async programming and really complex use of lifetimes, is just kind of beyond what I will ever understand. So even though I say I'm a Rust expert and I have a lot of Rust experience, I sure screw up a lot. But that's part of the fun of this stream, is embracing the mistakes. Anyway, I think, yeah, what I wanted to do is kind of, did I have my sip here? Yeah, I'm refreshing myself and remembering to go back to our code scene. I just want to step back and admire this generic code we've written and to see if there's anything that pops out about it, like whether we can clean up anything anymore here. So again, we've created two functions, create packet and collect results. Create packet is pretty straightforward. I feel good about this. There's only two generic arguments here. This is all pretty understandable from a readability perspective. These bounds are pretty straightforward. And this, I don't expect this to change much for our other types of requests. This looks good. The collect results, I hate this though. This is really nasty. This is, it's not unreadable, but it's not easy to read. There's 4 generic types, pretty ugly. These names help. The naming of the fields helped. It would be nice if we could like document these better to explain like what these generic types are. But even here, I've given these pretty verbose generic type names. You know, in Rust, it's common to just say like A, B, C, D for generic types, but these all have explainable names. And this code, I do think extracting it into a generic function is the appropriate thing to do because this logic is not straightforward. So I'm feeling pretty good about it. I'm kind of not feeling so great about the organization here. Like for convenience of writing this, I just kind of dump these 2 helpers directly after the impl of client, but they don't really make sense reading top down with the rest of the code. I don't know. I'm kind of torn about how to organize this module. Right now it's kind of a mess. There's some other helper stuff here way down at the bottom of this module. And then here, these are part of the interface to the module. And then these little conversion trait implementations, you know, they got to live somewhere, but the actual implementation is so in the weeds. Like nobody wants to read this, right? It's really nice if you just hide these somewhere. So I'm kind of feeling right now like I want to reorganize these definitions just to beautify this module a bit. And I think after just what I just said about how unimportant these trait implementations are, I want to punt all these just down to the bottom of this module. So I'm going to go ahead and copy this and dump it all the way down here at the bottom of the module. We could even like put these into some other module, just completely hide them. You don't have to define trait implementations in the same module as the type that they're implemented for. So all these conversion traits, we're just burying them at the bottom of the module. There's just kind of implementation details. And anytime we need one of these, the compiler will pretty much tell us like you don't have a from implemented for this, or you don't have an into implemented for this. So let's just hide those way down here. And so now the order of this module is kind of like, you know, import business, then our main client. This is the API, the methods on the client. Now we have some helper methods, these are internal details of this module. And then again, here we have some public structs. These are more the interface again. So I feel like I want these public structs, since they're part of the interface, to kind of be up here near the top. So these little helper methods that we just wrote today, this create packet and collect results, I'm going to punt these down further because they're not part of the interface. And I'm going to put them probably after these other little helpers. No, maybe before. I think this will read more top down if we put these before. And I'll put a lot of space between the sections of this module. Four blank lines between sections of this module. All right, so now these are like structs that are part of the public interface. These are the results of requests. create account result. The naming I'm still not happy with here. We have lots of things that are results. Like there's 2 levels of results here. There's create account OK, which also contains a create account result. So I can't, naming is so hard, right? But I'm not going to decide this now. I'm just going to keep living with it. But these types are all part of the results of requests. But this account type here, this is kind of a redefinition of a core Tiger Beetle type. So I want that to read first. And I'll even put some space here because we're probably going to be defining, 6 to 8 of these redefinitions of core Tiger Beetle types. So I kind of want them to have their own section. This is drop impl for client. This is kind of tough to decide where to put drop impls because they're kind of important. Like the fact that a type implements drop is somewhat important. But like the actual implementation itself is usually almost always trivial. So we could bump this all the way to the end of the module. But for now, I'm going to leave it right here. Noting that we haven't actually implemented close on the client yet. This may be something we can do right now before we end this stream because it's just a matter of writing the right FFI code to close the client. Right now we're leaking something, whatever's in that client. But I'm pretty happy with the organization of this now. And I might go ahead and make these imports non-pub. They were pub before for experimentation, but now we're getting to the point where we fully abstracted the underlying C bindings. We might not ever need to test the C data types. But I'm going to do another check to see if this works. Commit a checkpoint. And now I'll try to make these non-pub. I'll put those together. This is just renaming TB_client to TBC for convenience within this module. And this is all looking pretty good. Feeling okay about this code now. Pretty organized, pretty easy to read except for that one monster method. Let's go ahead and think about how we're supposed to close a client. And I think to do that, we should look at the TB client header in C. So again, we have a close function here, and our drop for client just delegates to close. But here we're not actually calling close, so we're just leaking whatever's in this client in the underlying C library. So let's just see real quick if we can figure out how to handle this before we finish the stream. TB client.h, I think. And this should define some functions. Hopefully we can find them easy enough. TB client init, TB client completion context. We're not using this yet. I don't know if we ever need this or not. We're not using it though. Submit we're using, dinit. This is what we need. So, and you can see here that this is interesting. There's no possible error case for dinit in the underlying library. But we've just said that, maybe we can handle an error on close here. And I'm wondering if it's really possible that there could be no error here. I mean, it's probably related to the async cancellation problem, right? Where a lot of the work on the TB client is happening asynchronously in another thread. So if you have some error resulting from closing here, they're probably going to show up as callbacks in that other thread. So maybe it's truly not possible to error on close here. But I'm also kind of suspecting that when we close, there could be outstanding requests happening. And maybe we want to do something like what order do those outstanding requests get resolved if we call close? Like we call close and it's saying yeah, we want to close the client, but we probably can't actually free all the resources from the underlying client yet because those are running in another thread, maybe in the middle of parallel, in parallel servicing those requests. And it would be nice to be from a caller's perspective, you might want to say close and await the close. So maybe this actually returns a future here. And it's say, ask for a close, and then we will, await the close. And then while we're awaiting that close, there'll be some internal code that's like, just wait for all the outstanding work to be done. Because on the Rust side too, we have to actually like free all the heap allocations we made at the very least. So I was thinking, 5 minutes ago, maybe this was something we could resolve right now. But now I am a little, it seems a much harder question. Like we can call close, but really maybe we want to do an async await and return a future here to kind of let the caller understand that the client has truly finally closed and everything's cleaned up. And I kind of, in fact, want to kind of express that in the API right now. Like you can call close and that'll trigger the close process. But remember, there's all kinds of asynchronous stuff happening behind the scenes. So when close returns, the cleanup is not actually done. There's more work happening. But we should be able to return a future here to say like, okay, start closing, then go wait for the close to finally finish in its multi-threaded way. So I do want to kind of express that here, even if I don't know how to implement it right now. We might have to kind of punt on that, but I kind of want to express it here so I remember in the future, like, yeah, we want to have some kind of async cancellation here. So to do that, we're going to say this is not a result anymore because we're not going to get any feedback immediately. Calling dinit internally doesn't do anything, or it doesn't result in immediate work being done. It just kind of says like, we're trying to cancel. So instead of a result, this is going to return an impl of future of result. And this result, this is an anyhow result. Anyhow is a library in Rust for easily handling results. So it's kind of existential result. Some kind of error happened here, an existential error. It says some kind of error might happen here, but I'm not giving you a way to express like the error type. It's just some error. And so that seems okay. We're going to return a future, and you can wait on that future to like confirm that like, yeah, all the close work is actually done. And also maybe some error happened during that time. It'll be kind of yet to be seen whether this is actually possible of returning an error or not. Maybe it won't be. And here, this is going to have to be an async block because we're returning an impl of future. And here we're going to put a to do, and let's just type check this again. And again, this is going to be, we need to capture this self, and I want to explicitly say we're going to capture this self lifetime. And I'm going to just copy paste this use s from my other definitions. This is a fairly new way in Rust to say that for this implementation of a trait, which is future, these are the lifetimes that are captured. So I need to define the s lifetime and put it here. And there's implicit rules about capturing lifetimes, but they're complicated enough, as we've talked on previous streams, that I don't want to just rely on the implicit lifetime capture rules. It's too complicated. I want it to be explicit in the signature. This should compile. Let's check that. It does not compile. This future, I said this wrong. This is not a type parameter on future. This is an associated type called output. Difference between type parameters and associated types is more complicated than I remember offhand. All right, this type checks. So now here we can say, okay, actually, no. Yeah, we'll say okay for now. But we're in this async block, not in the async block. Before the async block, we want to call dinit. And then in the async block, we can, to do await on cleanup. And then we return okay. But here, we're just going to immediately say tbc tb client submit. Nope, tb client dinit. And I'm cribbing off of this code here that is probably behind my face on your screen. And we just pass self.client, I think is the name of this field. Right here, client. That's the handle to the underlying client. And this returns nothing. And then here we can await for cleanup. So in this case, where we're just calling drop implicitly, we call close. That calls tbClientDinit. This future gets returned to the drop function, and we immediately drop the future. So we also have to kind of be aware of what happens if we drop the future here. But this all seems, you can't guarantee that this code is ever going to get run. So we have to, be aware of that. All the actual safety stuff has to happen elsewhere because this code may never run. It's in the future. But that's for another time. I don't think I really want to deal with that right now. I just want to get this outlined. This is an unsafe function. And this is holding a mutable reference, so this can't be called twice, at least not at the same time. We kind of have some little problem here that you could call this function close. Okay, we want to think about what happens if you can call close multiple times. We call close this once, we return a future. The future is holding this self-reference to close, so it can't be called immediately again. But after it awaits on this future, this is still just holding a reference to client. Client has not been consumed by this close function. And in fact, the Rust drop function can't consume a value. So really this close function, after you've called close, it's kind of going to leave the client in a dirty state. So if you call close twice, we could end up calling tbClientInit twice. And we really don't want to do that. I mean, we could look at the implementation of tbClient. Maybe it handles the case where it's called twice. And then panics, perhaps. But we really, in this case, a common pattern in Rust where it's like, the type is destroyed. Type is destroyed like in spirit, but the type lives on, the value lives on. We really need to have like a sentinel value to say like this type can't be used anymore. Like so we could do something like null out this field. And then in every single method, we have to check that that field has been nulled. Another thing we could possibly do is like make this take by value. So you call close by value, and then the client is no longer exists for the caller to call it anymore. And that's kind of a neater thing to do. The big problem with that is that drop is not by value. So if we made this close by value, then we gotta work around to the drop implementation to kind of synthesize a new client to call close on. And really, I feel like in the API we're designing, it's kind of much neater to just say like, this is by value. You call close, and that's the last thing you ever do with the client. And then we'll have to kind of deal with the ugliness and drop. But let's get this type checking as we've written it first, and then we'll kind of deal with that question. All right, so I think let's go for it. Let's try to make this close by value. And so now we don't need to capture anything, but we can also say plus tick static just to make it obvious we're not capturing anything. Yeah, let's do that. And here we call self.clientClose. And now that we've consumed the client, we kind of want to make sure that client does not implement copy or clone. Like a client is going to be what do they call it? An object with identity. Like you can't just copy your clients around. The client, if we copy the client, then we could copy the internal handle. So client is not going to be copied. So here when you close the client, it's consumed and the caller can no longer do anything with it. So this should all compile again, except now our drop is not calling client close correctly because drop only has a reference to self. It doesn't have a by value self. So the way we're going to deal with that is we're just going to fabricate a new client right here. I'm going to say client is self.client. So the internal handle we can copy as much as we want, but we're never exposing that internal handle to the user of the REST API, so they can't copy that handle. But here we're just going to copy the handle. We're going to call close on it. And close returns a future, of course. But here we can't await that future, so we're just going to immediately drop that future. This looks to me like it'll work. And let's just run it and see if this doesn't panic. Oops. Let's figure out if there's anything obvious we can debug right now. Oh, interesting. So before we were talking about what happens if you call close 2 times, close multiple times. And there's an assertion that we've hit inside of the library that says it's already shut down. Why would that happen? You see, here's our backtrace from our drop method, and it's saying it's already shut down. I wonder why it's already shut down. Let's go look at our main function. This is unexpected. I did not expect this to happen. Oh, okay. I know what's happening. I think I know what's happening. So what happens here is our drop method creates a new client and then calls .close on it. So here we pass this close in, we pass the client in by self, we close the client, but then this self item goes out of scope somewhere down here and then calls drop again. So it's going to go recursively, just close and close and drop and close and drop and close over and over the same internal handle. So like before when I was saying we have to have some sentinel value to indicate that this object is destroyed, we kind of can't get away from that. To prevent this infinite recursion of drop creating a new client and then calling close and then calling drop and then calling close, we still have to have some sentinel value that terminates that recursion, which is kind of a bummer to me. And I'm kind of wondering, like, is this pattern something we actually want to do or not? But just based on what I know now, I do kind of want to have an explicit close that takes a by value self, which means we got to add, more gnarly junk into the drop, which is not uncommon in Rust. In Rust, often drop has to jump through hoops. Drop is pretty special. So what I think I want to do here, this client, I know that this client this is an opaque type for us, but it's a pointer. So what I'm going to do is I'm going to assign this client to 0. I'm going to assign a 0 to this client right here. So we're going to de-init the client. And then I'm going to say self.client equals stood pointer null mute, I think. Hopefully this will work. I think internally this is just a type def of some kind of pointer. And this will assign it to a 0 pointer. And then in drop, we have to check whether this is actually a null pointer or not. And say if not self.client.is null. I think that's a method. So if it's not null, we'll close it. But if it is null, then we've recursed and we need to not drop again. Pretty gnarly. Again, not really loving that, but I think that's the thing we have to do. Cannot assign because we haven't made self mutable, but here we can say mute self. There we go. So now we're dropping. We could also, in our main, we could say, instead of dropping implicitly, we can say client.close.await ? And then this will close and then await for the future to be like really closed. There we go. This all seems to work. And for now, I want to keep dropping though, because that logic is tricky. So I want to catch in the future if we break this drop logic. And then sometime in the future, we'll figure out like what the real requirements here to figure out when the close is fully asynchronously closed. I suspect that's something we want to do, but Maybe I'll be wrong. So let's checkpoint what we've got here. And refresh ourselves. All right, chat. I think I accomplished everything I intended to accomplish today, and the next bit of work is going to be a little bit more than I can deal with this afternoon. So today we took the patterns that we've implemented for implementing 2 different requests to Tiger Beetle in the Rust client, and those 2 requests were basically copy pastes of each other with slightly different types involved. So today we spent our time extracting methods out of those requests in order to deduplicate that code. The methods we created 2 methods, one for constructing the input packet and one for interpreting the results from the server. One of them was pretty straightforward, really good refactor. The other one created a really gnarly method with a lot of generics on it that is pretty tough to read. But overall, the reading the callers of those 2 helper methods is much nicer now. And as we implement the remaining 6 Tiger Beetle requests, it should be much less error prone. That copy pasting of all those unsafe code, really had a lot of potential for writing errors, which I have written many errors copy and pasting that code around between requests. So I think overall, this is probably a good change that we've made here. But the future will tell. Writing code is always about kind of relearning and iterating and discovering the mistakes you made and rewriting and making things incrementally better. So surely some of the decisions we made today will have to reverse in the future. Next time, though, we're going to start implementing those remaining requests. We're kind of on the home sprint now, home stretch for submitting a PR and getting an initial version of this patch ready for people to test. I suspect it'll still be a matter of months before it's like fully polished, but functionally it's in a good place now. Again, my name is Brian Burson on GitHub, BRSON. My socials are on my GitHub IO page there. I'm doing this stream irregularly, but with some frequency, a few times a week. No schedule yet, but perhaps I'll set up some kind of schedule in the new year. All right, it's been fun. I thank everybody for coming out and hanging out and enjoying what we're doing. I'll see you next time. Peace.